Good evening, dear students. Today we are going to discuss application of derivatives. And before I proceed further, could you please confirm few of you that you are able to view the screen properly and able to hear my voice very clearly?
Yes, sir.
Yes, sir.
Okay, great, thanks. A couple of confirmation is sufficient. So now, dear students, during the differential calculus, we learned how to find derivative of composite function, inverse trigonometric functions, implicit functions, exponential functions, and logarithmic functions. Now, in this class and the other classes also, so this application of derivative class will run in few sessions. So in this class, we will study the application of derivatives in various disciplines, that is in engineering, science, social science, and many other fields. For instance, we will learn how to use derivative to determine the rate change of a quantities, to find the equation of tangent and normal to a curve at a particular point, to find turning points on the graph of a function, which in turn will help us to locate points at which largest or smallest value locally of a function occurs. We will also use derivative to find intervals on which a function is increasing or decreasing. And also we will discuss the derivative, use the differentiation to find approximate value of certain quantities. So I hope you find this is very interesting. So as I say, the application of derivative, if I say that, it actually constitutes this, 5 different, applications. So I'm going to show it to you. So the 5 different applications work in the application of derivative, that let me show you. That first one is that, approximations and errors. Second one is, the rate measurement. Third one, as you see, tangents and normals. The fourth one you see, maxima and minima of functions. And fifth one is the mean value theorems. So we will discuss, in this sequence, dear students. So let us start with approximation and errors. So let's first understand what is approximation. Now, as you know, dear students, I always prefer to give an example and before discussing the theory in details. So first we are going to discuss that approximation and errors. Let's first understand approximations. Then to it comes errors. Okay. Suppose one example is that we want to find the approximate value of suppose we want to find the approximate value of cube root of 25. Okay. Suppose if you do not have calculator, and if you need to find the approximate value, you need to find the value of cube root of 25. That means, you need to find 25 power 1 by 3. Okay. Now, how differential calculus is going to help us to find the value of 25 power 1 by 3? We will see, like this number. So that is called approximations. Now, the value what we are going to get, 25 power 1 by 3, using the differential calculus, will not be very accurate. If you use calculator, you will get more accurate value. So now, as we are not getting accurate values, there is definitely some errors. So that we will discuss during the, that's why it is called the errors. So before errors, we need to know what is the approximations. Now, you may think, sir, if your after application of differential calculus to find the approximation value, if you get slight error, then why you are using differential calculus to perform the approximation of some quantities? The answer is that if you do not use differential calculus, and if you do not have any calculator, it will be a very cumbersome task. Think about that. You do not have calculator and you need to find the value of 25 power 1 by 3. It will be a very costly affair, right? It will take long time. It will be very long time it will take, right? So that is why but if you know the differential calculus method, without having calculator, you can find a value which is very near to the exact value of 25 power 1 by 3. And we will see how it is. To start with, dear students, so we will define a function. Okay, so let y equal to fx be a function, and x is defined over a domain D. Okay, so what is that? So we have a function y equal to fx, and whenever a function is defined over a domain D. Okay, and D is a subset of a real number. That means it is a real valued function. Correct? Now, from the knowledge of differential calculus, dear students, what we know? What we know about f dash x? We know about the definition of f dash x like this. The value of this limit, delta x tends to 0, f of x plus delta x minus fx divided by delta x, that is equal to f dash x. If you recall, dear students, our class on differentiability. So this is coming from the that is the fundamental definition of f dash x. So what does it mean? It means that the limiting value of f of x plus delta x minus fx by delta x is equal to f dash x. That means what, dear students? That means as limiting value of this quantity which is there in the second bracket in the left hand side is equal to f dash x. So that means we can write f of x plus delta x minus fx divided by delta x is equal to f dash x and a very small quantity, suppose epsilon, a very small quantity. Now, what is epsilon? Where, let me write properly, where epsilon is tending to 0 as delta x is tending to 0. Correct? So limiting value of f of x plus delta x minus fx by delta x is equal to f dash x. That means what? The absolute value of f of x plus delta x minus fx by delta x would be f dash x and plus a small quantity called epsilon, where epsilon is tending to 0 as delta is tending to 0. Correct? So from here what we can write, dear students, is that we can write f of x plus delta x minus fx is equal to f dash x into delta x plus epsilon into delta x. Correct, my dear students? I hope it is well understood. Now, let's look into the quantity epsilon into delta x. We see that epsilon is a very small quantity and delta x is also very small quantity. No? So let me write delta very properly so that you can understand clearly. Okay. So what I want to mean is that this is delta. This is delta. Now, dear students, that if delta x is a very small quantity and epsilon is also very small quantity, then delta x into epsilon should be even smaller quantities. Take two very small quantities and make their product. The result, that is what is the product, that will be even smaller. Correct, no? For example, 0.02 is a very small number and 0.003 is also a small number. Now, if you multiply 0.02 and 0.003, that will be even smaller number. So from a sense of approximation, we can ignore that term epsilon into delta x. So then what we are going to get? We are going to get f of x plus delta x minus fx is equal to f dash x into delta x is equal to f dash x into delta x. So what we can write is that approximately we can define, we can write this thing approximately as epsilon into delta x is very, very near to 0. Correct? So then what we are going to get? We are going to get that f of x plus delta x minus fx. That means what? It is actually delta y, right? Because y is equal to fx. So the moment we get f of x plus delta x is what? Y plus delta y, na? And fx is what? Y. That is equal to, so f dash x into delta x. That implies what we are going to get, dear students? Delta y is equal to f dash x into delta x. So from this equation that, the delta y is equal to f dash x into delta x, that is also you can write is that f dash x is nothing but dy dx into delta x. So this equation, what I write in the within the red box, this equation, from this equation we can conclude that if delta x is an error in x, then the corresponding error in y is delta y. This small value of delta x and delta y are known as differentials. Okay. So now what we are going to use is that there are some terminologies we are going to use. That is called absolute error, relative error, and percentage error. So let me define this thing. All these things you have done in your physics classes, dear students. So these are the terms I am defining it here. Is that is called absolute error. Delta x is called an absolute error. Relative error is delta x by x is called relative error. And percentage error is known as delta x by x into 100 is called the percentage error. Now, we have discussed the fundamental theorem behind the approximation and errors. Now, let's take a couple of examples to understand very well. Okay, dear students? The first example, what I'm going to take is like this. Let me first, give the question. Let me, place the question in front of you, and after that I will explain it in details. So the question here is that, dear students, if y is equal to x to the power 4 minus 12, y is equal to x to the power 4 minus 12, that means y equal to fx, that is a function. Okay. And if x changes from 2 to 1.99, what is the approximate change in y? That means initial value of x is 2, then the final value of x becomes 1.99. So that means there is a small change, dear students. What is a small change? That is 2 minus 1.99, that becomes 0.01. Okay, that small change happened. Now, due to this small change, what is the change happening in the y? How to find it out? Okay, one way to find it out without using the differential calculus is that you find the value of 2 to the power 4 minus 12, and then you find the value of 1.99 power 4 minus 12, and then subtract it. It will take a long time, dear students, because 1.99 power 4 is not easily doable. So then what we are going to take care? We are going to leverage the concept of differential calculus. So what is x changing from? x is changing from, x is, so let me write it down, dear students. X is changing from 2 to 1.99. That means, what is delta x? Delta x, so this signifies that delta x is equal to 1.99 minus 2. Correct or not? 1.99 is the final value and 2 is the initial value. So delta x, the change in x, is 1.99 minus 2. And that is equal to minus 0.01. Then, dear students, we need to find delta y. Due to this change in x, let the approximate value of y become delta y. Approximate change in y is delta y. Then how are we going to find delta y? So the way we can find delta y is pretty simple. We know that is dy dx into delta x. Dy dx into delta x. So now, what is dy dx, dear students? Y is equal to x power 4. So, sorry, here we see, let me use a different color. So what is given? Y is equal to x power 4 minus 12. So then what we can find dy dx? Dy dx will be equal to 4 into x cube, dear students. So this value of dy dx we are going to apply here. That means what? So this implies, so let me go back to the red color. So this implies delta y is equal to 4 into x cube into delta x. Now, the point is that the value of 4 of x cube, that you need to evaluate at the value of x equal to 2. So when we say that dy dx, that is at x equal to 2. So 4x cube, that should be at x equal to 2. Correct or not? So I can write like this also. That is at x equal to 2. So from here, what we can write, dear students? Delta y is equal to 4 into x cube. So 4 into 2 to the power 3 into delta x. Delta x is minus 0.01. Now, if we find all these values, dear students, that becomes minus 0.32. So how much time it took? It took very less time to find the changes in y, minus 0.32. I explained very slowly. That's why it took more time. But if you do it, fast, it will not take much time. So the approximate change in y is minus 0.32. Correct, no? When x is changing from 2 to 1.99. Correct, dear students? Now let us take another example. Okay, so this is where we make the changes. The next example, what I'm going to do, dear students, is that we are going to find the approximate value of square root of 36.6. Very likely to come this kind of questions comes quite often in exam, dear students. So understand the way to do this kind of problem. So next one, what I'm going to do, dear students, is that to use differential to approximate 36.6, square root of 36.6. Okay, so let me show you how this can be done. This is question number 2. And also, look for the pattern the way I'm doing. And you need to apply this type of pattern, okay, whenever you get similar type of question. So what is here? Square root of 36.6. Okay, so here the function we are going to define is that, let me use a different color. Here we are going to use a function called y equal to square root of x. So, and let x equal to 36 and delta x is equal to 0.6. Delta x equal to 0.6. Then x plus delta x become 36 plus 0.6, that is 36.6. Correct or not? So then What we need to find? We need to find the value of, square root of 36.6. So let us derive one by one. If y equal to square root of x, then what will be delta y? Delta y should be square root of x plus delta x minus square root of x, correct or not? So this is equal to square root of 36.6 minus square root of 36, correct? So that implies what? That implies delta y is equal to square root of 36.6 minus square root of 36 is 6. So from here what we get, dear students, square root of 36.6 is equal to delta y plus 6, correct or not? Now all we need to find is the value of delta y, and here we need to take the assistance of differential calculus. So how to find delta y? We know that delta y is equal to, so just a minute, let me make it consistent. So I can write here is that instead of this delta, I can write just delta y. So that because I wrote in different symbol for x, no? So it is better to write delta y like this, delta y, delta y. So this implies, now what we know about delta y? Delta y is nothing but dy dx into delta x. Delta x we already know, that is 0.6. And what is dy dx? If y is equal to square root of x, dear students, then what is dy dx? Pretty simple to do. So if y is equal to, if y is equal to square root of x, this implies dy dx is equal to minus 1 by 2 root into x, correct? 1 by 2 into root into x. So that value of dy dx we should apply here. So if we apply here this value of dy dx, so what we are going to get? Delta y is equal to dy dx is 1 by 2 into square root of x into delta x. So what is the value of x here, dear students? The value of x is 36, correct? And eventually we get the value of delta y is equal to 1 by 2 into square root of 36 into delta x. Delta x we already found, we already designed in such a manner that delta x is equal to 0.6. So from here what we get, dear students? From here we find the value of delta y is equal to 0.6 by 2 into 6, that is 12. So you will get it 0.05. Now if you look into this one, square root of 36 is equal to delta y plus 6. Square root of 36, I request you, dear students, so please do not make any noise. Okay, so what we get is that, delta y is equal to 0.05 we got. And this equation, if you see, dear students, that square root of 36.6 is equal to, what we get is that, delta y plus 6. So from equation 1, what we are going to get, dear students, that square root of 36.6 is equal to delta y, that is 0.05 plus 6. That implies square root of 36.6 is equal to 6.05. That is the required value of square root of 36.6. And here you use differential calculus to find it very efficiently, dear students. I hope you understood it very clearly. So this particular, question, that is square root of 36.6, tells us that how efficiently we can, first design the function, that is y equal to square root of x, and then find the value of x and delta x such a way that x plus delta x will be whatever has been given to find it out, that is 36.6. You see, here we took x equal to 36 and delta x equal to 0.6, so that if we add them together, we get 36.6. And then we proceed for the next one. Let me take another example to make things more clear. Okay, and you need to do some more practice, dear students, so that it will become extremely understandable. So, for example, the next question, what we are going to take is that this one, that use differential to approximate 25 power 1 by 3. So let's discuss one by one. So we need to find the value, approximate value of 25 power 1 by 3. Now, one thing to pretty sure is that our function is going to be y is equal to x to the power 1 by 3. That is our function. But what is x and what is delta x? That we need to find. You need to choose x in such a manner that x to the power 1 by 3 will give you an integer. And also you need to choose delta x such a manner that if you make x plus delta x, you will get 25. And if you take x plus delta x, you will get 25. So what we can do? So the first thing what we can do, dear students, is that we can take x is equal to 27. If we take x is equal to 27, then we know 27 power 1 by 3 is what? It is equal to 3. And at the same time, delta x, if we take minus 2, then x plus delta x become 27 minus 2, that is 25, which is given in the question. So this is the two things important, dear students. First is that what is the function? That is relatively easy to find it out based on that 25 power 1 by 3. That's why you took y equal to x power 1 by 3. In the previous example, you see 36.6 power 1 by 2, that is square root of 36.6. So we took y equal to square root of x. Next part is that to choose x and delta x. So we choose delta x like, delta x is equal to minus 2. So now this implies what? This implies x plus delta x is equal to 27 minus 2, that is equal to 25. Correct or not? Now what we are going to find it out, dear students? We are going to find it out that delta y. Okay. So what is delta y? Let's find it out first. Now we need to find delta y. Let me write it here. So if we need to find delta y is equal to dy dx into delta x. Sorry, just a minute. Delta y is equal to dy dx into delta x. Now, what is dy dx? Y is equal to x to the power 1 by 3. So from here we can find dy dx very easily, dear students. If y is equal to x power 1 by 3, then what will be the value of dy dx, dear students? Tell me. So the dy dx will be, so here it will be 1 by 3 into x to the power 1 by 3 minus 1. Correct, na? So from here what we get, dear students? We get dy dx is equal to 1 by 3 into x to the power 2 by 3. So 1 by 3 into x to the power, 1 by 3 minus 1 is minus 2 by 3. So but if we take it from the denominator, it becomes 2 by 3. Correct? Now, so it is now easy to find us that what is the value of delta y. So the value of delta y is now becomes, so this value we can apply. So this implies delta y is equal to dy dx, that is 1 by 3 into x to the power 2 by 3 into delta x. What is x? X is 27. So that implies what? That implies delta y is equal to 1 by 3 into 27 power 2 by 3 into delta x. What is delta x? Delta x we took as minus 2. So if we find this value, dear students, that is minus 2 by 3 into 27 power 2 by 3, you will get minus 0.074. I am not spending time in calculating this because this is quite simple. So from here what we get, dear students, delta y is equal to minus 0.074. That is the value of delta y. Now what is our target? Our target is to find the value of cube root of 25. Right. Now let's look into that. So this let me give this then 1. So what is y plus delta y? Y plus delta y is nothing but x plus delta x. If we can write is that f of x plus delta x. So this implies what? This implies delta y is equal to f of x plus delta x minus y. Minus y means it is fx. So that implies delta y is equal to, what is f of x plus delta x? So let me write it down, f of x plus delta x minus fx. So dear students, let's write it down. So from here what we can write here is that delta y is equal to, what is f of x plus delta x? That is x plus delta x power 1 by 3 minus fx. Fx is what? X power 1 by 3. Correct or not? That is delta y. Now what is the value of x in context to our question? The value of x is 27, and value of delta x is minus 2. Correct? So then what we are going to get is that this implies delta y is equal to delta x. X is what? X is 27 and delta x is minus 2. So 27 minus 2 power 1 by 3 minus, what is x? X is 27 power 1 by 3. So from here what we get? What is the value of delta y? From this equation 1, we get the value of delta y is equal to minus 0.074. That is equal to 27 minus 2 power 1 by 3 is equal to 25 power 1 by 3 minus 27 power 1 by 3 is nothing but it is actually 3. Correct? It is 3. So from here what we get? That approximate value of 25 power 1 by 3, that is equal to 3 minus 0.074. So what we, give me a minute. So I get reduced. So let me make it in the proper size. Yeah. So 3 minus 0.074, that becomes 2.926. So from here what we get, dear students, that approximate value of 25 power 1 by 3 is equal to 2.926. I hope it is you understood it very clearly, dear students. Okay. The next point, what we are going to discuss is that it is called the next application of differential calculus is that rate measurement. Dear students, I hope that you have studied rate measurement in physics as well. Okay, in kinematics and other relevant problems we have discussed rate measurement. But let us revisit that topic and also let's understand that how rate measurement actually happens and how we can apply it in kinematics and also in curves to find tangents and normals, dear students. Okay. So the first one, what we are going to discuss is that, is called the rate measurement. Let y equal to fx be a function of x. Then the value of dy dx at x equal to alpha, that is f dash alpha, represent the rate measurement, rate of change of y with respect to the rate of change of x at the point alpha. So let me show you what is meant by that. Okay. So let me write down the definition first, dear students, and followed by let me explain you. Let y equal to fx be a function of x. Then dy dx at x equal to alpha, that is f dash alpha, represent the rate of change of y with respect to rate of change of x at the point x equal to alpha. Now, if you have a question, sir, how it becomes rate of change? Okay, then I will suggest you to go to my other video lectures on differential calculus, where I defined that how the dy dx is actually being derived from the concept of rate measurement. And you can look into this video lectures. It is available in the online platform at www.konarclasses.com, or you can also make a search in YouTube like Konar Classes Differential Calculus. You will find it out. Now, let's let's take some practical example of it. The first one is coming from the velocity and acceleration of kinematics. Let a particle start moving at a straight line and it covers a distance s in time t. So let me show you, dear students, and after that we will. The first one is that velocity and acceleration. So what it says is that let a particle start moving in a straight line and it covers a distance s in time t. So here s is a function of t, definitely, because as time goes by, you can calculate what will be the distance traversed. Let v and f be the velocity and acceleration of the particle at t. And we get the following relation. V is equal to what? We know velocity equal to ds dt, right? And f is equal to dv dt. dv dt is further we can write is the ddt of ds dt. Eventually we get it as d2s dt2. So this is one application of differential calculus that that how to find the velocity and acceleration. Correct, dear students? Get it? The next one, what we are going to do is that we are going to discuss about the the application of rate, how rate measurement is actually being used in tangents and normals. Okay. Okay. The next one is that tangents and normals. So, before explaining that what is tangents, before explaining the application of differential calculus, let us first explain you that what is meant by tangent and what is meant by normal. Okay. So let me first draw the coordinate axis, dear students. Suppose we have a curve something like this, y equal to fx. This is the curve. Now let us take a point. Let me take that point in different color. Let us take a point, P on that curve. So what will be the coordinate of the point P? If we take the x coordinate is alpha, so y coordinate should be beta, which is nothing but f alpha. So we can write the coordinate of the point P is alpha comma f alpha. Now, dear students, if we draw a tangent, let me draw the tangent in a green color. If we draw a tangent to the curve y equal to fx at the point P, so the tangent will look like something like this, correct? And what is normal? Normal is nothing but another straight line which is perpendicular to the tangent at the point P to the curve y equal to fx. That means what? If we draw the tangent in a different color, like so this looks like the tangent in normal. Okay, so what you see in the green color straight line, that is the tangent to the curve y equal to fx at the point P alpha comma f alpha, and the line what you see in the blue color, that is a normal to the curve y equal to fx at the point P alpha comma f alpha. What we are going to do? We are going to find the equation of these tangents and normals at the point, alpha and f alpha. How to find that one? Okay, so the equation of the tangent to the curve at the point, alpha comma f alpha, that is, we can consider also as a alpha comma beta, where beta is equal to f alpha. So that means what I wanted to mean is that we can also consider that coordinate of the point P as alpha comma beta, where beta is equal to f alpha. Now, before defining the equation of the tangents and normals, dear students, one thing we are going to discuss is that what is dy dx in this context to the tangent. Okay, so dy dx, that is f dash x, represent the slope of the tangent to the curve at any point xy on the curve. That is what is called dy dx. So then dy dx at the point alpha comma beta, that is f dash alpha, represent the slope of the tangent to the curve at any point alpha beta on the curve y equal to fx. Correct or not? So that's what we are going to write it down, dear students. Okay, so let me take it from the study material and let me explain you this thing. So please have a look into the following two statements, dear students. So now we can conclude the following statements for tangents to the curve y equal to fx. dy dx, that is f dash x, represent the slope of the tangent to the curve at any point x comma y on the curve y equal to fx. And dy dx at the point alpha beta, which is the second statement, dear students, is that the dy dx at the point alpha comma beta, that is f dash alpha, represents the slope of the tangent to the curve at any point alpha beta on the curve y equal to fx. So beta is equal to f alpha, as I wrote here also. Correct. Now, what we are going to, so as we understood about the slope, now it is very easy to find the equation of the tangent. Correct or not? So equation of the tangent is very easy to find it out. So how to find the equation of the tangent? Let me show you. So dear students, we find the equation of the tangent to the curve at any point alpha beta on the curve y equal to fx, which means the relation beta equal to f alpha is true as below. Y minus beta is equal to dy dx at the point alpha comma beta into x minus alpha. That means y minus beta is equal to f dash alpha into x minus alpha. And this is a very important equation to the tangent to the curve y equal to fx point alpha beta on the curve. Fine. Now let's look into the normal. One thing though, we are pretty sure, dear students, that as the normal is perpendicular to the tangent, then the product of the slopes of the tangents and the normals should be equal to -1. And we are going to apply that concept to find the equation of the normals as well. Let's see how to find it out, dear students. Okay. So let me take that particular statement from the study material and let me explain you further. So as you see, dear students, that, and we conclude the following statements for normal to the curve y equal to fx, that is minus dx dy, that is -1 by f dash x, that represent the slope of the normal to the curve at any point x, y on the curve y equal to fx, that is minus dy dx at the point alpha comma beta, that is -1 by f dash alpha, represents the slope of the normal to the curve at any point alpha comma beta on the curve y equal to fx. Correct? Now let us find what will be the equation of the normal. Okay, dear students, so let me find the equation of the normal. Let me take it from the study material. So dear students, eventually we get the equation of the normal to the curve at any point alpha comma beta on the curve y equal to fx, which means the relation beta equal to f alpha is true, is y minus beta is equal to minus dx dy at alpha comma beta into x minus alpha. So what we can say is that this equation, thus y minus beta is equal to minus 1 by f dash alpha into x minus alpha, is the equation of the normal to the curve y equal to fx at the point alpha comma beta on the curve. Correct, dear students? Now the next point what we are going to discuss, that is about the length of tangent, normal, subtangent and subnormal. So let's discuss about this point. Okay. So let me bring that topic from the study material. Let me place it here and then let me explain you, dear students. So to understand the length of tangent, normal, subtangent and subnormal, let me take help of this pictorial diagram first. Okay. So here is a pictorial diagram, dear students, as you see. You know that curve y equal to fx, as you see here, it is that is the curve y equal to fx, and at the point P on the curve there is a tangent. So suppose we can define T as the tangent to the curve y equal to fx at the point P, and suppose we can define N is the normal to the curve y equal to fx at the point P. Then that tangent makes an angle theta with the positive direction of the x-axis. This is the angle theta, dear students. Okay, and that tangent intersect the x-axis at the point T, and the normal to the curve y equal to fx is intersect the x-axis at the point N. So then we get these are the points also. T is the point, I repeat, dear students, that capital T is the point of intersection of the tangent to the curve y equal to fx at the point P with the positive direction of x-axis. And similarly, T is the point of intersection, no angle here, sorry. T is the point of intersection of the tangent to the curve y equal to fx at the point T, at the point P with the x-axis. And what is N? Capital N. Capital N is the point of intersection of the normal to the curve y equal to fx at the point P with the x-axis. Fine. Then what we are going to say, dear students, is that PT is called the length of the tangent and Pn is called the length of the normal. What you see, that's PT, that length is called the length of the tangent. That means the line segment from the point P till the tangent intersect the x-axis, that point PT is called the length of the tangent, and similarly Pn is called the length of the normal. So let me write it down here, dear students. After that we will discuss the next point about the length of subtangent and subnormal. So what I was telling, dear students, is something like this. Whatever you see in the background, there is a watermark that is from from our study material. So let Px comma y be any point on the curve y equal to fx. Let the tangent and normal drawn at the point P to the curve y equal to fx meets the x-axis at the point T and N respectively, as I already explained few minutes back. Then what is the length of the tangent, dear students? Pt is called the length of the tangent, and that is nothing but mod y, that is the y coordinate of the point P, into square root of 1 plus dx dy whole square. And what is the length of the normal Pn? is equal to mod y into square root of 1 plus dy dx whole square. Now, without having the differential calculus to finding this value pt and pn is not that simple. So here also we see that differential calculus is helping us to find the length of tangent and normal. Now, what is subtangent and subnormal? Now, if you look into the diagram, dear students, that let the point P1 be the projection of the point P on the x-axis. Okay, then what we can say? We can say that TP1, that line segment, that length of that TP1 is called the length of the subtangent, and NP1 is called the length of the subnormal. So then what we can say, dear students? We can say these two statements and show length of the subtangent and subnormal, where P1 be the projection of the point P on the x-axis. Okay. Clear, dear students? Okay. Now, what we are going to discuss is about the angle of intersection of two curves, and that will be the last topic for today, and that will make a logical conclusion. And here it is. So, what is meant by the angle of intersection of two curves? Okay. So here you need to take two curves in. So let me write it up. Sorry. Let me take it from my study material, dear students, and all of you will be able to get this study material in the online platform. Sorry. So what we are going to discuss is called the angle of intersection of two curves. You may be thinking, sir, I heard about angle of intersection of two straight lines. But how come that angle of intersection of two curves happens? We know to happen angle, we need to have two straight lines intersect and we measure that angle. But curves are not straight line, sir. So then how come that intersection of two curves and we get an angle? Interesting point if you have this question in your mind. So let me discuss this point. So, let me first put this, note here, and then let me explain you. So it will be more clear to you then. So what is there, dear students? Let y equal to fx and y equal to gx be two curves. You see, this is the curve y equal to fx, and this is the curve. So there are two curves. Y equal to, there are two curves y equal to fx and y equal to gx, as you see, dear students. Okay. Now, as we see these two curves, that y equal to fx and gx, now the angle of intersection of these curves is defined as the acute angle between the tangent that can be drawn to the given curves at the point of intersection. Correct? This is explained by means of the following diagram. Let me explain you by means of the following diagram. What is that? That suppose, these two curves, as you see, y equal to fx, they intersect at the point P. Now, at that point P, if we, dot tangent, then the acute angle between the tangents, so these are the two tangents, this one and this one, okay, to both the curves at the point of their intersection. In this case, you see this, they are actually touching each other, but that is also true. Then that angle between these two tangents is actually known as the angle between the two curves. Clear, dear students? I hope it is clear. So again, I can explain you by means of this thing, is that suppose I have a curve something like this. Okay, so this is a curve y equal to fx, suppose. And another curve I have, let me draw it in the green color, is something like this. Suppose this curve is equal to y equal to gx. So now, what is meant by the angle between these two curves? The meaning of the angle between these two curves is that suppose I draw a two tangents. They intersected at the point where the intersection at the point this. Suppose this is the point P. Now at this point P, we draw two tangents. First tangent to the curve y equal to fx. This is the tangent to the curve y equal to fx at the point P. And the next one I am going to draw the tangent to the curve y equal to gx at the point P. It will be something like this. Now we get two straight lines, dear students. One is the blue line and the purple line. Now the acute angle between them, so that means what is the acute angle between them? Acute angle between them is this. If this is theta, then we can say the angle between these two curves y equal to fx and y equal to gx is nothing but that theta. Okay, dear students, so this is what is called the angle of intersection of two curves. Now what we are going to discuss, dear students, is that, if we take the coordinate of the point, if we take the coordinate of the point P as x1, y1, then obviously we get y1 equal to fx1 and y1 equal to gx1, and then we are deriving these two important points. So let me show it to you here. So let the curve y equal to fx and y equal to gx meet at the point P x1, y1. Okay. Now, sorry. So as you see in the curve, okay. So the coordinate of the point P be x1, y1. x1, y1. Correct. So we get y equal to fx1 and y equal to gx1. Let m1 and m2 be slopes of the tangent to the curve y equal to fx and y equal to gx respectively at their point of intersection. That means if we can say the slope of that curve, slope of this line, purple line, it is m1, and slope of the blue line become m2. Then what we can find m1 with the help of differential calculus? It is nothing but the value of dy dx. That is ddx of fx at the point x1, y1. That is the way we found the tangent and normal now. In the previous section we discussed. And what is m2? That is ddx of gx at the point x1, y1. Now if theta be the acute angle of intersection of these two curves, that is theta be the acute angle between the tangents that can be drawn to the given curves y equal to fx and gx. That is the, as you see in the adjoining diagram as the blue line and the purple line, then we can use the concept of two-dimensional geometry straight lines. What is the acute angle between two straight lines having slope m1 and m2? So this is equal to tan theta is equal to mod of m1 minus m2 by 1 plus m1 m2. If someone wants to know that how it is, please refer to my relevant video lectures on points and straight lines as available in the online test platform at konarclasses.com. Also, it is available in YouTube. You can just go to youtube.com and search with, in the search key, you write that Konar classes straight lines. So from here, what you get, theta is equal to tan inverse of mod of m1 minus m2 by 1 plus m1 m2. So where m1 and m2 are obtained from the equation 1 and 2, as you see here, m1 is obtained from here. Okay, and m2 is obtained from here. Correct. Now here few points we need to take a note of it. The first point, what you can say is that if theta equal to 0, then m1 equal to m2, that means the given curves would touch each other at the point P x1, y1. And if theta is equal to pi by 2, then what we can say that m1 into m2 is equal to minus 1, means that the given curve would meet at a right angle at the point Px1, y1. Okay, on the other way, we can say that the curves are orthogonal to each other. That means the curves cut orthogonally at the point P x1, y1. So this is all about what I wanted to discuss for today. In the next class, dear students, that is on Monday, we will be discussing about the monotonicity. Before that, I will strongly appreciate you to please look into the video lectures as available on differential calculus, both in in the Konar classes platform as well as in YouTube. With this note, I would like to conclude the class for here, dear students. Thank you very much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank
Thank you,
you.
sir.
Thank you. Take care.
Thank you, sir.
Thank you. Take care.